to explain the working of a lens as a combination of a glass slab and two prisms. Will be first drawing the full lens, convex lens, and after drawing the lens, rub out this portion with the eraser and rub out this portion with the eraser, and then draw this line, draw this line, draw this line and draw this line, meaning the topmost portion will be a prism, the middle portion will be as a glass slab, and the lower portion will again appear as a prism. That means there are two prisms and a glass slab. Same way, you can draw a concave lens, initially complete concave lens, and then erase some portion with the help of eraser and erase some portion with the help of eraser here, and then draw two lines, one with the prism and one with the glass slab. Here also one line and the another line. That means you are dividing a complete concave lens into three pieces. The top portion is a prism, that means flat surface prism we can say. Middle will be a glass slab and the third portion will again be a flat surface prism, because the lenses are taken very thin one, so we can treat them in the same manner as if we are using the prism and a glass slab. The flat portion does not make much difference in the explanation. If you are asked any time to treat them as a combination of prism and a glass slab, you have to show the activity on the basis of the prism and a glass slab. So to do that, what we are going to do, we'll take the first ray straight incident normal to the glass slab, which will move undeviated. That means on the top of the principal axis itself we can say the ray has been shown incident normal to the glass slab, which moves undeviated. Same way in case of a concave lens also, the middle portion is the glass slab, and the ray moves undeviated because it is incident at 90 degree to the glass slab. Now coming on to the activity of the prism. If a ray of light is incident on the prism always bends the ray towards the base of it. That means the ray of light parallel to the prism will always bend towards the base of the prism, and it will be passing from F2. Similarly, the another prism also, if the ray of light is shown incident on the prism will bend it towards the base of it. And because the base of the prism in this particular situation is upper side, so the ray of light is going to bend. And all three rays are going to meet at a point which is the focal point of the lens actually. So all three rays, they are going to meet after refraction at a point F2, and thereby showing the converging nature of the lens. Same way, to show the nature of the lens on the basis of the prism and the glass slab, the parallel ray which is passing from the prism will be moving towards the base of the prism. Now the base of the prism is above. As a result, the ray of light is moving towards the base of the prism, and it will appear to be coming from a point F2, which is the focal point of the concave lens. Similarly, another parallel ray if I take, the ray of light will be bending towards the base of the prism. Now this is the prism, so the ray of light is bending towards the base of the prism, and it will appear to be coming from the point F2, which is the focal point of this concave lens as a combination. If I combine all three parts, the prism, the glass slab and this another prism, it will appear to be a concave lens. And by showing the ray passing from the prism, the another ray passing from the another prism, and the third ray passing from the glass slab, will find the rays will be meeting at one point F2, and it will be indicating the concave lens and its diverging nature.